Welcome to another installment in the cyp-c Research Champion webinar series. My name is Jason Pohl. I'm the director of this course, and today I'll be talking about using SAS and an introduction to some procedures. And originally I had scheduled a data cleaning talk today, and I apologize if that's what you're here for. The data cleaning talk will actually be delivered next month, and I realized actually that I needed to introduce you to some of these procedures that we'll actually be using during the data cleaning for you to have a sort of understanding of what we're going to do at that point. So today, as I said, it's an introduction to the procedures, that many of the basic procedures that you'll be using in SAS. And just as a note, all the lines have been muted, and at the end we'll open the lines up for questions. So I just need to make this go. There we go. So just as an overview of what we're going to talk about today, I'm just going to sort of revisit the SAS overview again, and then I'm going to introduce you to a number of SAS procedures. I'm going to introduce you to the frequency procedure, the print procedure, the means procedure, the univariate procedure, the sort procedure, and the contents procedure. And I think you're going to see some overlap in the way that SAS procedures and commands are developed, and hopefully I'll point some of those out as we go along, and you'll see that they're applicable to many other procedures that I'm not introducing. So this is a very short list of procedures that SAS can actually perform, things that SAS can actually do, and I'm also not going into the detail of all capabilities of each of these procedures that I'm presenting today. I'm going to present to you what I feel are the sort of the overall or the basics that you need to know in order to be able to use these or get started to using these. Of course, all details of all SAS procedures are actually available on the web. SAS has all of their manuals web accessible. So if you ever run into problems or you think Proc freq should do something and it's not doing it, you can literally just Google SAS Proc freq, and it will take you, the first hit that you'll find actually will take you to the SAS manual where you would be able to find the details of everything, in fact, that the procedure could do. So just a little overview again of SAS. So for our purposes, there's really only two major things that SAS can actually do, and I know that seems rather simplistic, but in actual fact that's true. There's the data step, and this is used to manipulate the data in some way, and we've already covered a fair bit of this when we talked about reading in the data and subsetting the data and a few other things in previous talks for this series. And then, of course, there's the procedure step, and this is really used to analyze data or produce tables, and it can also be used to estimate regression models. Things like regression models will be introduced further on in this series in the coming months, but for now we're going to look at the procedure step for the first time, really, and show you how you might be able to use the procedure to actually start looking at your data, if you will. So to start with the Proc freq procedure. So the Proc freq procedure really allows you to get an n-way cross-tabulation of your data. And by n-way, I mean that could be a simple listing or frequency of the values that are stored in a particular variable, or it could be as many cross-tabulations as you want. So obviously a bivariate table or with two factors that you're looking at, which I'll introduce you to, but you could actually extend that out to 3, 4, 5 different factors, and SAS is happy to do that for you. There are some basic statistical tests that actually Proc freq can do, and I will describe those to you today. It can perform more than what I'm actually showing you, so this is one of those times where if you think it could do more, please check out the manual online. So the basic syntax for the freq procedure is to say Proc freq, and then there's a series of options that you can actually use with that first line of code. There's a bivariable that you don't need to use, but you can, and I'll show you how to use that. And then there's a tables code or syntax that you need to use, and this is where you actually request the variables, in fact, or the tables that you want SAS to build. And then there's a number of options that you can actually use when creating those tables, and then, of course, a run statement to tell SAS that you actually want to run that procedure at this point. So the only two required statements to run the Proc freq is actually Proc freq and the table statement. So we'll just start with a few examples here. So here you can see that I'm using Proc freq, and I've said data equals T7. And so this data equals T7 is actually one of the options where you can actually specify the data set, in fact, that you want SAS to do the Proc freq procedure on. If you don't, it is optional. If you omit this, it will use the last data set that SAS touched. So whatever was the previous data set that you were working with, SAS will actually do the frequency on that. So you can leave this out. As a matter of good coding, I feel that you should actually specify the data set that you want the frequency procedure to be run on. I think it's just a little more implicit, and therefore you know exactly what you're going to get. There are, as I said, other options, and we'll see some of those as I introduce more of this procedure. The next syntax there is tables, the tables command, and here I've asked for tables of QAI, PPE, and gender. So you might recall that we've seen this T7 data set before, so this actually is a data set that Dr. Lillian Sung and I are using to perform an analysis using cyp-c. So these are actual variables and data that you'll see from the data set. The QA-IPP is actually an income quintile per single person equivalent. This is really the measure of socioeconomic status that's derived from postal code that most health analyses use in Canada. And that was added to our data set as part of our data request. And then gender, obviously, is gender. So when you run this procedure in SAS, this is what you end up with. You'll notice here that the first table that you see is actually for the income per single person equivalent. As I said, it's a quintile where 1 is the lowest quintile and 5 is the highest. And you'll note here that the table gives you a number of things, and I'm going to walk you through that. The first is that for every level of the variable, there's only 5 levels of the variable here, and you'll see that there's a line of data. And so for income per single person equivalent value equal to 1, you'll notice that there's 1,754 times that this appears in this particular data set. And that represents 19.4% of the data. And the cumulative frequency here is actually the same because it's the first value that's come up for this, and the cumulative percent is exactly the same as the previous percent. But you'll see when we go down to value 2 for income, or SES, you'll see that there's 1,769 individuals, or times that appears in this data set. That represents 19.56% of the data. But now you'll see that the cumulative frequency is actually adding that 1,769 to 1,754, which is the frequency from the previous values that it's seen. And so now we have a cumulative frequency of 3,523, and that represents 38.96% of the data. And this kind of frequency in percent and cumulative frequency and cumulative percent follows through until it reaches the end of the values that are available. So you'll notice that when you get to level 5, as I said, there's only 5 values, you'll notice that the cumulative frequency then is 9,043, and the cumulative percent is 100. Now, it turns out that, in fact, there are a few more records in our data set than 9,043, and that's actually specified at the bottom of the table where it says frequency missing equals 161. So this tells us that there's 161 observations in this data set that does not have the income per single person equivalent assigned to it. And when you ask Proc freq to create a table of a variable, it will always leave the missings out or put them at the bottom of the table. It will specify them, but it doesn't actually use them in the calculations. Now, sometimes it's important to actually know what the distribution of the missings are, particularly when you get into tables when you're looking at more than one value, which I'll show you in a second. And sometimes you also want to know what that percentage is. So what's the percentage of missing here? Well, you would have to calculate that by hand, or I'll show you in a second that you can actually get SAS to calculate that for you. So the second table that we requested was for gender. Of course, gender has 2 values in this situation, and you can see down here that the frequency, percent, cumulative frequency, and cumulative percent are specified. Again, there's 5 individuals or 5 records in this data set where actually gender is actually missing. So as I said, sometimes you actually want SAS to calculate that missing for you or put the missing in the table is the way that we describe it. And so to do that, actually, you just add the \missing option to the tables line. So what this does is it actually now moves that 161 patients or subjects up into the table, and you'll notice that SAS's sorting always sorts missing first. So you'll notice that the missing category always comes first in the table. So now you'll notice that that 161 individuals is there as the first line of the table. That represents 1.75% of the data, and again, the cumulative frequencies and percents are calculated, as you can see. So in total, there's 9,204 observations in this data set, and just depending on how you, whether you want it to calculate the percentages with or without, the missing values, you can use this \missing command. So the other thing that you might want to do is actually you would like to know what the distribution of socioeconomic status is by gender. And so you can use this by command. The only caveat with using a by command in any procedure in SAS is that the data set must be sorted in that order prior to actually running the command. So if it wasn't sorted by gender, SAS would actually give you an error and tell you actually that it needs to be sorted before it could do anything. And we're going to cover the sort command a little bit later in today's talk. So here we ask for a Proc freq of data set T7. We want it by gender, and we want the socioeconomic status values done. And we've added the \missing command, which therefore indicates to SAS that we would actually like the missings calculated in the percentage and into the tables. So the first table that comes up, of course, is where gender is missing. So you can see across the top that these are actually the stratifications. The by variable actually creates stratifications for you in the data. And you'll notice here that there were 5 cases where gender was missing, and this is the distribution of cases by income per single person equivalent. It turns out that there's one person who has the socioeconomic status missing, one person has a value of 1, one person has a value of 2, one has a value of 3, and one has a value of 5. So the next table that gets generated is for gender equal to female, as you can see here, and then it gives you the distribution as you would expect. And then finally, you can see here that you get the distribution of males. So you basically get 3 tables. It basically creates a stratification when you use the by variable. Now, sometimes you'd actually like to know what the joint distribution is between socioeconomic status and gender, or 2 variables or more. And in that case, you can actually put a star between the variables that you would like the tables to be crossed by, if you will. And then SAS will actually generate a table for you that looks like this. So you can see here that the first value that you ask for always goes on the, I guess, down the left-hand side of the table, and the subsequent values that you want actually go out to the right. And you can see here, because we use the \missing command, the missings actually are all in this table. So now you can actually see how the missings distribute, both by gender and socioeconomic status. So this table is actually quite complicated. You can see that there's a bunch of numbers in here, and we're going to walk through basically what these are. So right now I've just highlighted again where gender is equal to missing, and you'll notice at the bottom of the table it gives you a count of 5, so that's a marginal total. And then it gives you what that distribution is by socioeconomic status. Likewise, you can see here that there's 161 individuals that we know have SES status missing, and you can see what that distribution is by gender. And then it gives you a few of these things that we've already seen. We've seen percent already, so I'm not going to go over that. But there's these 2 things that are added now called row percent and column percent. Row percent, so it basically calculates the percentages based on the row. So now what I've highlighted here is the first, or is the SES status equal to 1. So this is the lowest socioeconomic status. And I've said now, given those 1,754 individuals that have a socioeconomic status of 1, what proportion of them had gender missing, what percent of them were female, and what percent of them were male. And you can see, actually, I've accidentally highlighted the wrong ones. It should be, the red bar should actually be a little bit higher. So the percentages actually should be 0.06, 45% were female, and 54.9% were male. And that overall represents a percentage of 19% of the data. Now, likewise, when we go to column percent, this has highlighted the right thing, you'll see here, now this says, taking this column where gender is equal to male, what's the distribution or proportion of each of the socioeconomic status values? So you'll notice that 1.87% of the data is actually missing amongst the males, that 19.41% are equal to 1, and so on all the way down the table until you get to the very bottom of the table where it gives you the marginal total, and that says that 53.9% of the actual subjects were male in this case. So this is a basic outline of how to read these 2x2 tables. And of course, you can create these 2x2 tables for any values that you wish, including completely continuous values. The tables will just get very large and quite unwieldy. And SAS has no problem producing tables that are quite large. It just puts a continued on and keeps spreading them over the pages as you wish. So sometimes you just want to summarize the data, or sometimes you really might think of this as more of a way to describe categorical data versus continuous. We'll talk about some procedures that might be better to describe continuous data shortly. So that table can be quite confusing and a little bit cumbersome sometimes, particularly if you're going to use more than two values cross-tabbed together. So here we're only cross-tabbing socioeconomic status and gender, but if you were going to add a third variable or a fourth variable to this, you can imagine how it would get the tables would get quite messy. And in actual fact, what you can do is you can actually add the \list command here. So I'm still including the missing command, but now I've added this command called list. And what does this actually do? Well, it produces a table that looks like this. So this basically summarizes that table I just showed you previously, but now just lists out the values. So you'll notice that there's all the values are here with the exception of the rows and column percentages. And you'll notice that you can see across the table each of the permutations and combinations that were available in the previous table. So you can see that in the first row, it's where socioeconomic status was missing and gender was missing, and that actually only occurs once, so the frequency is equal to 1. The second row down is where socioeconomic status is missing, but then gender now is female, and that occurs 67 times. Likewise, the third is where socioeconomic status is missing, gender is male, and that occurs 93 times, and so on through the table. So sometimes the \list command is a little bit easier to deal with. It's a little bit more of a compact way to look at the data, and sometimes a little bit easier to use subsequently. So often I will use this if I'm going to then retype these values, for example, into Excel to create tables for a paper, and actually I'll have Excel actually calculate the percentages, the row or column percentages for me, because Excel can do that quite easily and quite fast. So the other thing that I said Proc can do is that it can actually do some statistical analysis for you. So one of the things that you can calculate is actually you can calculate things like chi-square. And so that, again, is another option in the tables command. And you can see here what I've asked for is the chi-square using the CHISQ command or option. And so what that does is it generates the table as we expected. Notice that there's no \ missing here, so I haven't included the missing in the table. So you'll notice now at the bottom of the table it says missing is 165. So that's actually the total number of people that have any of the values missing, so both socioeconomic status and or gender missing. And then what you would get in the SAS output is statistics for that table. And you get a number of various statistics. I'm not going to go through in detail all of the nuances of these things, but you'll notice the first one is actually the chi-square. It has 4 degrees of freedom. It gives you the chi-square value, and the probability is 0.17. So you can see actually that you could actually get differences for example, between males and females in this case, but you might actually be able to calculate differences between cases and controls, or differences between two various other groups that you might want to compare on a particular variable. So I've already mentioned the missing down at the bottom. That's right. So the other thing that you can do is you can actually calculate other measures of association. And the CMH command actually stands for Cochran-Mantel-Hansel. And so you'll notice here now what I'm doing is actually I've introduced a new variable called dumb-ALL. So dumb-ALL actually stands for dummy ALL. So it's a dummy variable that tells me it's a variable that I've created that has 2 values, and it's basically a flag that indicates whether the individual had ALL or not. So in our data set, it turns out that there's 2,137 individuals that had ALL and 7,062 that did not have ALL. And of course, I didn't ask for the \missing here, so the missings are actually appearing at the bottom of the table. But I did ask for the Cochran-Mantel-Hansel, and what that does is actually create some summary statistics looking at these. And you'll notice that the first one is a case control value, so that's actually an odds ratio calculation there of 1.138 with the subsequent confidence interval already provided. And likewise, if this was a cohort study, it would calculate a cohort risk measure, so a relative risk measure, and so those are also calculated for you. Of course, SAS doesn't know whether your data is actually from a case control study or a cohort study, so it just calculates everything for you, and you need to know which value to pick off the table. So it automatically provides as a default the 95% confidence interval, but as I said, there's a lot of options here, and you could actually change the alpha level to something else if you wanted a 90% confidence interval or a 99% confidence interval, for example. but 95 is the most common, and hence why that's the default option for SAS. So this table now, again, I'm generating a table now with 3 values. So I'm going to use dumb ALL, gender, and income per single person equivalent. You can see the options I've requested here are list and missing. And you'll notice that the table that it generates now is very similar to the previous table that we looked at, but now you'll notice that it stratifies everything by dumb ALL. So now all of the people who don't have ALL are at the top of the table where dumb ALL equals to 0, and everybody that does have ALL is at the bottom of the table where it equals 1. And again, you can produce as many crosstabs as you like using the Proc freq procedure. It does have a limit, mind you, so if you're using a very large data set and you're getting up around 15 or 20 variables, it may tell you that it's reached its limit. Part of it is actually related to your own system that it's running on and how much memory it can have to actually generate this table. Needless to say, I have never gotten into a situation where I actually wanted the table that I was requesting and SAS wouldn't produce it for me. So it will produce quite complicated tables for you in terms of stratifications and counts. So that was all I was going to say for the Proc freq procedure, and now we'll move on to the Proc print procedure. So the Proc freq procedure basically summarizes some of the data. It aggregates the data and then provides for you counts and frequencies for that. The Proc print procedure really is just going to print out data from a data set, and you can actually control some subgroups and other various aspects of that printout. But essentially, it is just a printout of your data set. And the one thing to note about Proc print is that it's going to print the observations in your data set based on the order they're currently in your data set. And of course, you can modify the order that the observations are stored in your data set by using the Proc sort procedure, which we're going to talk about a little bit later. So here, the basic command for Proc print is proc print, and then there's some options, and then a semicolon. There is bivariable processing, and you can add the variable list there. And here, instead of using the table statement, you have to use the var statement. So this stands for variables. So what variables would you like proc print to print? And then you specify those variables, and then there's also some options that you can apply to those variables, and then the run statement. The only required statement here for proc print is actually proc print and then run. So you don't need to specify a by group if you don't want your variables by group processed, and you don't need to specify var. In fact, if you left var out, it would actually just print out everything in your entire data set. Now, if you have a very large data set with a lot of variables and a lot of observations in it, again, it can get quite large, but SAS has no problem printing it for you. So I generally use the var statement because often there are some variables that I'm not interested in when I'm printing out the data set for whatever reason I'm interested in doing that for. So here, just as an example, we're going to use proc print, data equals T7 again, and I'm going to use just the var statement, and I'm just going to print out gender, income per single person equivalent, and DX date, which is the diagnosis date. So you'll notice here that there's kind of 2 outputs that I put here, and you'll see a red line. The syntax, or the way that I'm displaying this, is that the red line just demonstrates that it's actually one continuous table here. I've just cut out the middle for you. So as before, there's 9,204 observations in our data set, which you can see by OBS number at the bottom. And you can see here that the first 7 observations gives you, I guess, where gender is missing, and you'll notice then that income per single person equivalent is also there, and then the DX date. And you can see from this that it seems as if the data set is sorted by gender, and that's about it. So it does appear as if, I mean, without seeing it all or without actually knowing, it does appear as if the data set is sorted by gender, but it's not sorted by socioeconomic status clearly, and it's not sorted by date by any way. So as I said, the way SAS produces proc print is it prints out the observations as they're currently stored in the data set. So whatever way they're currently sorted in the data set is the way that they're printed. And the key here is that the observation number here is not a unique identifier that's applied to the data set. It is a unique identifier that's applied during the print procedure. So OBS 1, 2, 3, 4, 5 is actually just the observation order in which that they're stored in the data set. And if you resorted the data set and then proc print again, you would see that it goes OBS 1, 2, 3, 4, 5, and it would actually be different data potentially in those rows. So just keep note that the OBS printout number that's being given here in proc print does not reflect a value that's actually stored in the data set. It is specific to the proc print. So maybe now what I want to do is subset this and actually only print out all the ALLs. So I can use a where command. So I can say proc print data equals T7, and then I can say where dum ALL equals 1. So I'm basically saying wherever dum ALL equals 1, then I'd like you to print the following variables. And again, I'm just printing gender, socioeconomic status, and diagnosis date. And what happens here is that, again, you'll see that the observation seems to go to 9,204, which is the total number of observations we have. But you'll notice that some of the observations are missing. So in the obs numbers, you can see how some of them are missing. It turns out that actually we start with obs equals to 5. And then we go from 5 and we skip to 12. And then 13 comes right after it, but then we skip down to 26. And this is because the where command is actually just filtering out everywhere that dum ALL equals 0, or where it's, I guess, not equal to 1, technically. And so given that the sort order of the data set was by gender, it's just filtering everything out. And so it's giving you the observation number of how it's actually stored in the data set, but it's actually just filtering out those ones when it actually shows you or prints them out. So the other thing that you could do is you could actually by group process this. So we could use the by command here and put gender in, for example. And what that will do is actually create separate analyses as before by gender. Again, sorted the way that we expect, but now it's actually just going to display each of the genders individually as a continuous table. So proc print is not something that you would use as an analysis tool per se, but it is a very unique and useful tool when you're looking at your data and trying to figure out how some of the values are stored in your data set, or even to check when you recode something, did it actually code it correctly, that you can actually use the proc print procedure and actually go through and, print out the values of the variables that you were using in your calculation to see if it actually worked. And I often will do that and do 1 or 2 hand calculations just to make sure that the way I've asked SAS to do it is correct. So now we're going to move on to the means procedure. The means procedure allows you really to summarize data and compute descriptive statistics across various variables and also within groups. So this is now another way to summarize data similar to the Proc freq procedure. But this obviously is more in line with numeric data that is more continuous in nature. Now that's not to say that SAS won't take a categorical variable that you've stored in SAS as a numeric variable, similar to income per single person equivalent there. It's stored actually as a number between 1 and 5. It would actually do the means procedure on it, even though it is categorical. And sometimes that can be helpful, for example, when you're using a Likert scale analysis, for example. But generally, we reserve the proc means procedure for continuous variables where the number of individual values for that particular variable is really, really large, and using the proc freq procedure would give an enormous table, for example, and not terribly meaningful if it is actually continuous data. So the proc means procedure can calculate mean, it can calculate measures of variation, median, ranges, extreme values, and can also actually perform t-tests. So the proc means procedure is actually quite powerful overall, and I'll demonstrate a few of the things that it can do. So the general syntax for the means procedure is proc means, there's some options, and then there's some statistical keywords that you can use to get some of the statistics out. It allows you by variable processing. There's a new class statement that's introduced, which I'll explain. There's a frequency statement that you can use in case your data is actually already summarized. So sometimes you get given data that's already aggregated, and you can use the proc means procedure to help you with that. There's the ID procedure, and I'll explain how that actually works because that can be quite helpful. There's the output procedure in case you actually would like to output the means into a separate data set to then use in subsequent calculations, for example. And there's a variable list, basically the variables that you want to calculate the means on. So you'll notice, I'm hoping you're beginning to notice that the procedures that we're demonstrating here today have very similar options associated with them, or statements. And those statements and the way they work basically the same in all SAS procedures. So whenever there's a by statement that's allowed in a particular procedure, it basically works the same way across all the procedures. So once you understand how these things work in one procedure, it's the same kind of it's the same way it would perform in another procedure. So hopefully it won't be as overwhelming in terms of all of the options that are available for some of these procedures. But as a, as a starting example here today, we're again going to use the Proc means procedure looking at table T7. And the variable that I'm going to use now is called time death. And this is actually a variable that I've calculated here, and it's actually calculated as the number of days from the diagnosis until the patient died. So when you run this command, this is actually what comes back. So you'll notice here that it says the variable that's being analyzed is time to death, or time death, and it's, I've given it the label of number of days between diagnosis and death. And in total, there were 1,512 observations used in this analysis. And you might say, wait, there was over 9,000 observations in the T7 data set. But it turns out that in actual fact, there are only 1,512 deaths that are in the data set, and hence it's left out all the missings, if you will, where time death is actually missing, where it wasn't calculated because they didn't die. So we have 1,512 individuals who died, and the time to death is 6.24 days, and the standard deviation for that is 629.75. The minimum is 0, and the maximum is 4,527 days. So the minimum of 0 might seem a little bit strange to you, but someone actually can die on the day of their diagnosis and hence have a day 0. And again, when you have continuous variables like this, it's always good to run a Proc means procedure, even just to get familiar with your data and understand, does that seem reasonable? Does the minimum value seem reasonable? Does the maximum value seem reasonable? And does the mean seem reasonable in terms of what's happening? And of course, sometimes it doesn't, in which case you've probably messed up on a calculation or something's happened to your data that you don't quite understand. And so it's very good to use these procedures to sort of look at your data. And we'll talk about how to use these a little bit more next month when trying to clean your data. But as I said, here we have 1,512 individuals, minimum was 0. But now maybe we actually would like to calculate the mean time to death by gender. So again, this by group processing provides some stratification, and what happens is you get stratified data here. So now in the stratification, it is actually going to use where gender is equal to missing. So in the variable statement, in the var statement of proc means, it leaves out all the missing values for any of the variables that are listed there. But in the by statement, we'll actually use the missing values. So here we know that there's actually only one individual who died, who had gender was missing, and they died 621 days. Hence why there's no standard deviation calculated, because there's only one value, and the minimum and the maximum are equal to the mean. Next, you'll have the gender breakdown. So the first one here presented is where gender equals female. There were 693 deaths amongst the females at an average time of 574.1 days. Standard deviations, mins, and max are provided, and again for males. So the next procedure that I want to introduce to you is the class procedure. So the by procedure is really a stratification variable that allows you stratification. The class procedure is very similar to the by procedure, except for the fact that now when you use the class procedure, it's actually going to ignore the missings in this case, unless you tell it to do something different with the missings. And it's actually now going to basically provide us the same sort of output, but leave out the missings of gender. And the class procedure is sometimes important for some analytic techniques that we'll describe a little bit later. But depending on whether you want the output to include those missings or not, you could do it this way. So now, previously you'll notice that there was actually those stratification tables where it had the dotted line with the value. Here it's actually put it into a single table, and it's just basically stratified your data by gender. So it's essentially, it's exactly the same data that was produced the last time, just using this class statement. Now, all of these tables, as you'll notice here, have actually the one thing that I didn't talk about in this table here was that you now have this number of observations. So this actually tells you the total number of females in the data set, and then N actually tells you the number of people that actually had a value for the variable that's in the var statement. So there were 4,238 females in total, of which 693 actually had a death, and hence the means are calculated on that 693. you'll notice here that it's always giving you the n, the mean, the standard deviation, the min, and the max. And those are the standard statistics that are calculated using the Proc means procedure without specifying things. As soon as you want something a little bit different than that, you actually then need to specify everything that you want. And so you'll notice here in this particular SAS syntax, I still have proc means data equals T7, but now I've actually had to list out what all of the statistics are that I would like it to calculate. And I will go through shortly the various statistics that it's calculated. Again, I just want it by class and time. But essentially, you'll see that there's this much larger list of statistics that I now need to specify. So as soon as I want to deviate from the n, the mean, the standard deviation, the min, and the max, I need to then specify everything. So here, the number of missing just tells me the number of missing. So the n obs tells me the total number of observation is 4,238 in females. But the number who have a missing time death is equal to 3,545. And the n, which is the next thing I've asked for, is 693. And if you were to add 693 plus 3,545, you'll end up with 4,238. So you can see it's just giving you a distribution of how it was distributing. The mean is the mean that we've seen before. The standard deviation is the standard deviation that we've seen before. The standard error is something new here. So the standard error is something that I've requested. And the standard error is often used when calculating various things like the confidence intervals. So you can actually request the confidence intervals here by using confidence limits for the mean. So that's actually CLM, stands for confidence limits of the mean. And you'll see here that it gives you an upper and lower confidence level for the mean. And that's actually using the standard error that's produced. So you may not want to see the standard error, but it is actually calculating and using it in the background in order to calculate these confidence levels. And so you'll notice here that the mean for females time to death was 574.1 days, but the confidence level actually goes from 530 days up to 618 days. And again, here are the min and the max. And you'll notice the last thing that I specified here is max decimal equal to 2. This doesn't actually print anything in the table, but what it does is for all values that it's calculating, it just truncates the values to only 2 decimal places. Otherwise, it would calculate it to 8, 9, 10 decimal places, and it can just make your tables look a little bit messy. So the next thing that we might want to do is actually add the missings to the output. So as I said previously, when you use the standard option for using variables specified in the class or the var statement is to actually miss or skip the missings. But you don't want to miss the missings, because sometimes the missings are important. And so by using the missing command here, you can actually have the missings put into the table for you. And you can see here that gender is missing 5 times. 4 times they didn't have a time to death. 1 time they did, and that's 621. So this is just a way to sort of get back to using or including all of the variables in your or observations in your data set when looking at these things. So the final thing I wanted to talk about in terms of the means procedure is actually getting some output into another data set. So sometimes you would want this because you need to be able to calculate a mean and then add it back to the data set in order to use that in subsequent calculations for something. So the way to do that is actually using the output command that you see here. So there's a couple of additional things here that you'll see that I've added. So one is a no print command. So I've actually, in the options for the proc means statement, I've actually said no print. And what that means is it's not going to actually print the means table that you expect and we're getting out of the means. But it is actually going to do all the calculations. And that's kind of important. Because what we actually want is we actually want to output the data set. So we can use the output syntax here. And the output syntax says output, and that is just telling SAS that you want to output the data to some data set. And the out equals statement says that I want to output it to a data set called T7 underscore TTD underscore mean. So this is just my way of saying that it's the output for data set T7, time to death, and the mean. So it's the means of time to death for data set T7. And then here you have to specify what are all the values that you want to include in this data set. And you can name them as you choose. So what you do is you specify the statistic that's being calculated, and then after the equal sign you say what is the name of the variable that you want to call it. So here I've specified n-myth, equals nmiss underscore TTD. So this is just me saying that it's the number of missing time to death. And then I said n equals n underscore TTD for time to death and mean of time to death. And then subsequently I use the print statement to actually print the data set so that I can see it. You don't need to use the print statement, but I do like to see what's in the data set and see what's going on. Because you'll notice there's some additional things here that have appeared in the data set. You'll notice now that that automatically in this data set are two variables that I didn't ask for. So I asked for gender, obviously, because I asked it to class by gender. And then I asked for the number of missing and the n and the mean. But what I didn't ask for was underscore type underscore and underscore freq underscore. And so what are these variables? Well, type identifies the combination of classification variables whose values were used to create the analysis. So type equals 1 is really the grand overall set of calculations or means. So SAS automatically calculates for you for all 9,204 observations in the data set. It calculates all of the things that you've requested. So here you'll notice that the number missing time to death is 7692, which is really the number who survived. And the number with the time to death is 1,512, which is the number of people who ultimately did die. And the average time to death was 624. But now you'll see that the next observation then is where type equals to 1. And type equals 1 is really telling you what the first set of tables are for the class variable that you specified. So type 1 is really equal to the first variable that you specified in the class line, essentially. And so this is where gender, and so this is where gender equals missing, male, and female, and it calculates all of the statistics that we've requested for that. You'll notice here that it's included gender equals missing in this data set because we used the missing command in the proc means, the missing option in the proc means statement. So if you were to use more than one variable for the class statement, so say you wanted the mean stratified by gender and age, and maybe even diagnosis, you can imagine that the table will get quite large, and SAS would actually calculate all the permutations and combinations of the different types. You would end up with multiple types. So you would end up with the grand mean where type equals 0. You would end up with a mean where each of the permutations and combinations exist. And ultimately, what you're really interested in is where actually type is equal to the highest value, because that's actually where it specifies the individual values for each of the class levels that's available. One of the ways to just request this in the data set is to actually just add the n-way option actually to the proc mean statement. And then in actual fact, in the output statement, it would only give you the highest value of type. But sometimes actually having this information is useful, and hence why it's here. So that's the end of the proc means procedure, and we're going to move on and consider the proc univariate procedure. So SAS proc univariate really allows you to examine the distribution of data, and it also allows you to assess normality and identify outliers. And next month when we talk about cleaning your data, you'll see where actually identifying outliers is quite important. It can create many plots and run various statistical tests for you as well. Again, I'm not going to go through all this in detail. The syntax for proc univariate is very similar to the syntax for all of the rest of the procedures that I've demonstrated today, so I'm not going to go through that in detail. But here you have proc univariate data equals T7. The variable is dx age. So here I'm getting really some statistics for diagnosis age or age of diagnosis. I happen to know that this is calculated in years, and so we can see here that the total number is 9,204. The mean is equal to 5.95 years, so that's the mean age of diagnosis in this data set. The standard deviation for diagnosis age is provided here. And you might say, well, means could provide all this for me if I just ran the means procedure, and that's true. What this is actually going to give you, though, are things like skewness and kurtosis. It's also going to calculate a coefficient of variation for you. And then it's actually going to give you some basic statistical measures like median and mode, for example, so, and the interquartile range. So these are things sometimes that you want in order to put in publications, and the easiest way to get it might be from proc univariate. The other thing that proc univariate gives you is actually tests for location, what we call tests for location. So this is actually testing whether the distribution of the variable that you've asked for, in this case, diagnosis age, is actually different than 0. So hence why it says mu0 equals 0. So that's the null hypothesis. And here you can see that actually whether you use the student's t-test or the sign rank test, each and every time the p-value is less than 0.001, which is indicating, in fact, that the distribution is, or the mean is actually different than 0. You can, of course, set the value that you wanted to test this against. The default value is always 0. And then down below is the quantiles. So here it actually tells you, gives you a little bit more than the min and the max, because it actually gives you quantiles. So it tells you that the median age is 5 at the time of diagnosis, and it tells you that the 75th percentile is equal to 10, and the 25th percentile is equal to 2, which of course is your interquartile range. But then it also gives you some other percentiles. The other thing that it gives you when you use the Proc univariate procedure is the extreme observations. So here you can see what the observations are at the two tails. It prints, by default, the lowest 5 and the highest 5. And you'll notice here that it gives you the value that's stored, and then it gives you the obs number. But again, very similar to the print procedure, the obs number here actually references the way the observations are stored in that data set. So it's not actually that useful to go back and say, well, who actually had that extreme value, and be able to identify it in your data set. But there is a way to try and do that, and that's using the ID procedure here in Proc univariate. So you'll see that I've now specified the ID command, and then I want it to use the cyp-c ID. And so by using the ID command, when you run the Proc univariate procedure and you start looking at extreme observations, it actually tells you the cyp-c ID of those extreme observations, regardless of how the data is sorted. And so this will allow you to actually go back and be able to identify those individual records. You can specify the plot procedure here, and this will actually produce some plots for you. So here is a histogram of diagnosis age, there's a box plot, and a normality plot. So there are some things that Proc univariate will give you that Proc means will not, in an effort to help you really understand your data a little bit better. So this is where Proc univariate can be quite helpful. Again, you can use the class statement in Proc univariate as before, and you'll notice here that as with all class statements, unless you ask for missings, it will leave them out. So here you get gender for female, and then you get gender for male, and you get different distributions, different box plots, and different normality plots. So it's just going to produce all of the information, again, sort of stratified by gender, but using the class procedure. So that was all for the univariate procedure. We're now going to move on to the sort procedure. So SAS Proc sort, I think you've seen this already because I've introduced it a little bit in previous talks, but it really allows you to rearrange and sort the observations in your data set, either by character or numeric value. SAS doesn't actually care whether it's a character or numeric value, it will just sort it. The sorted data set, a sorted data set, as I noted here, is required for by-group processing. So I noted this previously, that if you actually use any of the by-group processing, SAS will demand, essentially, that your data set be sorted by this before they run that other procedure. The other the other neat feature of Proc sort is that you can actually make modifications to the data set using this procedure, and it can often speed up some of your coding. So again, the standard options and syntax for Proc sort are below, and the only difference here is this key command, which I will explain shortly. But here I'm running this statement here, so I'm going to actually print the data set before only the first observations of the data, the first 15 observations of the data set. That's what obs equals 15 means. Then I'm going to sort the data set by cyp-c ID, and then I'm going to print it again, and you'll be able to see the difference. So this is the first data set that is not sorted, and you will see that actually it seems quite haphazard in terms of cyp-c ID and diagnosis date. And then after I've actually sorted it by cyp-c ID and then reprinted it, you'll notice here that in actual fact now the cyp-c IDs are in numeric order, as you would expect. So SAS has actually sorted the data set, and then we reprint it just to see what it looks like. So again here, sorting the data by gender, cyp-c ID, and diagnosis date. So here I'm actually sorting within these groups. So what it does is it actually sorts by gender first. So it takes all the genders equal to missing first, and then it sorts the cyp-c ID within those, and then it sorts the diagnosis dates within those. And then it goes through and it takes everyone who's female, and it sorts the cyp-c IDs, and then it sorts the diagnosis dates. So you can see that this is quite a powerful procedure, and you can sort by a whole variety of different variables all at the same time. So here I'm actually sorting by cyp-c ID, gender, and diagnosis date. So you'll notice here, this is the first 15 observations, but you'll notice here that actually now the cyp-c ID is perfectly in order. Gender is not quite in order, and diagnosis date is semi in order. But this is because what it's doing is actually sorting the cyp-c ID first, and because that's unique for each and every individual in this particular data set, I've removed people with multiple diagnoses in this data set. It really makes no difference after that. Once I've sorted by cyp-c ID, it'll get sorted by gender and diagnosis date, but because there are no multiple observations within each ID, it actually isn't performing much of a task there. So the other thing I wanted to point out here is you can actually use the descending command before you specify any variable in the proc sort command, and it will actually sort it in the opposite order. So you'll notice here that by using descending gender, it's now sorted all of the males first. So previously we'd always sorted missing, female, and then male. But now I've asked for it in descending order, which means now it's actually sorted the data set by male, female, and then missing. Likewise, I've asked for descending diagnosis date, and so you'll notice that the diagnosis dates would be sorted in that order as well. So the last thing I just wanted to show you with regard to the proc sort statement is that you can actually sort the data and put it out into a new data set that's sorted in that particular way, and then you can actually modify what it is that you're actually keeping. So you can use this keep statement. So you'll see in the keep statement, I say, so I say in the out statement to actually output it into a data set called T8, and then I say in this keep statement, I say just keep cyp-c ID and diagnosis date. So this new data set called T8 that I'm creating is going to be sorted by the sort sequence that's specified by the by statement, but it's actually only going to include cyp-c ID and diagnosis date. So this is a way for you to be able to sort of manipulate or even do some what we had learned to do using the data step previously, actually using this proc sort procedure. Likewise, you can rename some variables at the time that you use the proc sort procedure. So here again, creating a same output data set called T8, but in this case, I'm going to rename the cyp-c ID equal to ID. And sometimes this is important when you're putting two data sets together where it's the same values that are stored in a particular variable, but it has a different name. And when it has a different name, SAS won't allow you to merge them like we learned with the merge command. And so one of the ways to actually rename the variables is the way that I'm showing you here using the sort procedure. So the proc contents procedure. The proc contents procedure really just gives you information about the data sets that are actually in your library. And the proc contents procedure is one of the more simplistic procedures, but tells you a lot of information. The syntax is just proc contents with a few options and then the run statement. And if we do a proc contents and data T7, this is actually what we see. So we see here that it tells us that the data set is called work.t7, and that it has 9,204 observations, it has 122 variables, and then there's some other information that may or may not be of interest to you. It does tell you whether it's sorted or not. And then towards the bottom of this output that I'm showing you here, you can actually see that it gives you a listing of all the variables. So it tells you the variable number, it tells you the variable name, the type, the length, the format, and the label that's been assigned. So this can be quite handy, and often I will create a proc contents for various data sets, particularly the analysis data set that I'm going to use, so that I know the values of my variables as I go along. So one of the things that it does is that it actually sorts them in alphabetical order unless you use the order equals option. So here I've used the order equals varnum option, and what it does now is it actually sorts the variables based on their var number. The var number is actually assigned, the variable number is actually assigned as when the variables got added to the data set. So as you're building the data set, the order in which the variables get added to the data set is the order in which they're going to appear here. And sometimes that's more helpful because often, previously when I showed you about reading in the data, we often read in the patient information and then we read in some diagnostic information, and so that's the way that this proc contents then would be sorted. So that was all I was going to cover today in terms of some of the procedures, but hopefully you have a better understanding of how to use SAS procedures in general, because you'll see the syntax is quite similar. And then we specifically went through some basic commands using proc freq, print, means, univariate, sort, and contents. So that was all I had for today, and I'll have Randy reopen the lines if anyone has any questions. And thank you all for attending.
Unmuted.
So Randy's reopened the lines. I don't know if anyone has any questions.
Yeah, absolutely. I need to Montreal.
Hey, Jason, it's Randy.
Hi.
Great talk. My only question was actually more related to the data. You said that's real data?
Yes.
This is very interesting. I'm assuming you have a paper coming out on that?
So this data is actually the data that we are using for our clinical trial analysis. Actually, one of those papers is already published, and there's a few other papers that are using the data for sure.
Yeah, just the male-female difference.
Yeah, I mean, keep in mind that I haven't actually told you what's totally in that data set other than I told you that I removed any duplicate diagnoses. So although you've seen real data, you don't have the full story, if you will, because you don't see all of my code that generates that data set. So you don't have a full sense of actually exactly what's in that data set, but you get some sense.
Yeah.
Any other questions?